the string data type. First, we need to define what is a string. We already know how to use it. If you want to read, let's say, letters, or if you more than one letter, then you need to define your variable as a string. So if we ask you to write a program to read your name, then your name consists of more than one letter, then it is a string. So what is a string? A string is a class data type that is used to create and process a string of characters. When we say string of characters, it means more than one character. What is a character? Just to remind you, a character is either a letter like this, or numbers like this, or any other symbol, okay, like enter, $sign, brackets, and etc. So we combine them all together and we call them characters. How characters are represented into the memory? If you remember that computers deal with numbers only, 1 and 0. So how a letter is converted? Usually characters are converted into codes, numbers. So a number as a code. Me and you also, we can have this code for communication. Suppose I want to send you a letter A using your computer. So my computer is connected to your computer by, let's say, a wire, and we are in different rooms. Suppose I want to send you the letter A. I could agree with you as a protocol. I will tell you, see, if I send you the number 1, then it means A. If I send you 2, then it means B. So this is like agreement. So I'm giving a code for each number. This is how it is done. Now, in computers, characters are given codes. They are called ASCII codes. Now, ASCII code is a standard code already developed years back by Americans. And at the same time, there was another code developed by European. It was called EBCDIC, but that one now disappeared. ASCII code is now become famous. So this ASCII code character is in fact 1 byte. So if you read it here, ASCII character set includes all the characters normally used in English. So any letter you use or any character normally used on an English language keyboard. Each character in ASCII code is represented by 1 byte. Okay, so any letter you want to send using this code, it is 1 byte. 1 byte binary number, which is 8 bits. If you have 1 byte, then the maximum number of characters that you can represent, انت تقدر تمثل أقصى حد عدد من الكودز. إذا عندك 1 byte is 256. So 256 if you have 1 byte. If I want to show you a sample of those ASCII codes, nobody remember all the table. Maybe by practice, if you try to look into the table, you will remember them. A sample of an ASCII code. Okay. For every letter, there is a code. See, for example, space, the code is 32. CB, the code is 66. CG, the code is 71. Even for numbers, okay, if I go down, see, for numbers also they have codes. So the code for 1 is not 1. The code is 49. The code for 4 is 52. So for every character that appears on the keyboard, some of them are not visible. Like, for example, the space is not visible. Even the ASCII codes, even the escape. See the escape you use on your keyboard, it has an ASCII code, which is a code 25. For the delete and for enter also, there is a code, and there are some special symbols that you can display on the screen. They have their own code. See, these are 255 different codes that is used by 1 byte. Okay. We go back to our presentation. But for other languages like Arabic, 1 byte is not enough because in Arabic language, 1 letter, it can be written in more than 1 shape. الحرف الواحد ينكتب بأكثر من طريقة. Is it in the middle? Is it at the beginning? Or is it at the end? So we need a code for each character because it will be written in different shape. Also, we have dialects. شدة, dhamma, sukun. So also we need codes for those. So 256 is not enough to represent all characters. So instead of using 1 byte, some languages they use 2 bytes. So that code is called Unicode. So a Unicode is another code. It is an extension of ASCII code, and it is used by many languages like Java, and also it is used by many browsers because the browser should be available globally to all languages. So Unicode consists of 2 bytes. So you are increasing the number of characters representing a string. So you can represent 65,000 different characters. So this is just the point to show you that how characters are represented into the memory. They are represented by code. So if you press A on the keyboard, then this A will go through the wire, will go to the computer, and will send the shape of A on the screen. So there is a communication between the computer devices using ASCII codes. How to represent a string? So for each character, it takes, if it is ASCII code, it takes 1 byte. So if I have the message, enter your name. Then if this is represented by ASCII code, then how many bytes it will need into the memory? It needs 1, 2, 3, 4, 5, 6. The space is also counted. 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So it needs 16. But if you represent it by Unicode, you need to multiply it by 2, which is 32. If you put quotation around any text, even numbers, then it will be a string. So this is not a number. This is a string. So if I ask you what is the size of this message, you just count 1, 2, 3, 4, 5, 6, 7, 8. It is 8 bytes. But if it is a number, it should be less because integer is represented by 4 bytes. So anything you put between double quotation will be considered as a string. To show you how strings are saved into the memory if the characters are represented by ASCII code or Unicode, consider the following example. We have a string called lab, and the data inside is lab hash number 1. If the characters inside the string are represented by ASCII code, then each character will take 1 byte. So look at the memory. The first data of the string, which is L, its ASCII code is 76, is at address 0239001. And for the next character, which is A, its ASCII code is 97, it is at address 0239002. So the addresses are jumped by 1 because each space is for 1 character. However, if you look at the data or the string, if each character is represented by a Unicode, which is the table on the right-hand side, see the addresses for each character. They are jumping by 2. So the first letter, which is L, which has the same Unicode as the ASCII code, which is 76, it is saved at address 0239001. But for the next character, which is A, and its Unicode is also the same as the ASCII code, which is 97, it is saved at address 0239003. So the first letter is taking 2 bytes in the memory. At 1 and at 2, and for the next byte, for the next character, which is A, takes the address 3 and 4, and for the next character, which is B, takes the address 5 and 6, and etc. Now, how to define strings in Java? You write a string, S capital letter, and you label the variable that you are going to use for this string. If you don't know the string that you want to save at the moment of defining your variable, then you can put a new value later. So now here, see, you are defining, then later you are saving. But if you know the value of the string at the time of your declaration, then you can simply assign it into the variable. What are the operations that we can use on strings? On numbers, we have addition, subtraction, multiplication. Now, on strings, what are the operations that we can do on strings? The first operation is called concatenation. And we have already used concatenation when we print 2 things on the screen. We use a plus. So plus, we used it in a print, not for adding, for combining. Combining معناته يضم, okay? One after the other one. So the technical word is called concatenate, concatenation. Here is an example. Suppose you have a variable name defined as a string and it has China inside. And suppose we have another string which is called the greeting, but I'm using a plus between a string constant and the variable name. So this plus will combine hi with China. See, I'm having a space here, because if I want to combine hi with China, then I need to leave a space. So the result of combining hi with name will be saved into greeting. So when we print the greeting, the output will be hi China.